In this video, we're going to look at another application of turning a Riemann sum into an integral. The question here is to express the limit as n goes to infinity, summation I goes from 1 to n, sine of pi over 2 times I minus 1 over n times 1 over n as a definite integral of the form 0 to 1 f of x dx and 0 to pi over 2 f of x dx. What is difficult about this question is that we have different limits of integration. So we have to adjust the x values to be compatible with those limits of integration. In the first definite integral, you will notice that we have a is equal to 0 and b is equal to 1. Whereas in the second definite integral, we have a is equal to 0 and b is equal to pi over 2. So we really have two separate questions. Recall the definition of a left-hand Riemann sum. Limit n goes to infinity, I goes from 1 to n, f of xi minus 1, delta x, that's equal to integral a to b, f of x dx. So that's the definition of the left-hand Riemann sum. Let's start with the first question, integral from 0 to 1, f of x dx. Now, you will notice here that we're actually given a is equal to 0 and b is equal to 1. And that means we can form delta x, which is by definition b minus a over n, which is 1 minus 0 over n. So let's put those in. A is equal to 0, b is equal to 1. That was given in the question itself. So now, what we're going to do is let xi minus 1 be equal to I minus 1 over n, where I ranges from 1 all the way to n. When I is equal to 1, we get x0 is equal to 0. When I is equal to 2, we get x1 is equal to 1 over n. When I is equal to 3, we're going to get x2 is equal to 2 over n, and xn will be n minus 1 over n. All right, so now let's look at what we have. We have a is equal to 0. That's a lower limit of integration. B is equal to 1. Delta x, that's equal to b minus a over n. That is 1 minus 0 over n. That's 1 over n. We chose our xi values to be xi minus 1 to be I minus 1 divided by n. So the functional values, f of xi minus 1, that's going to sample the left-hand points, will be sine of pi over 2 times I minus 1 over n. But this part is xi minus 1. That's sine of pi over 2 times xi minus 1. Well, that means that f of x is equal to sine of pi x over 2. So we now have all the pieces of the puzzle. We have a equals 0, b is equal to 1. We have the functional values f of x is equal to sine of pi x over 2. So we can now turn the Riemann sum into a definite integral. So let's rewrite the Riemann sum. We have limit n goes to infinity, I goes from 1 to n, sine of pi over 2 times I minus 1 over n times 1 over n. This is equal to the definite integral 0 to 1 sine of pi x over 2 dx. So this part here is f of xi minus 1 for the Riemann sum. This is delta x. This is f of x for a definite integral, and this is dx. We've turned the Riemann sum into a definite integral. So now let's look at the second part of the question, where we want to basically change it into 0 to pi over 2 f of x dx. So now the limits of integration have changed. We're going to let xi minus 1 to be equal to pi over 2 times I minus 1 over n, where I ranges from 1 all the way to n. So x0 is going to be, putting I equals 1 into the expression, we get 0. x1 is going to be pi over 2n. x2 is going to be pi over n. x3, plugging I equals 4 into this expression, and we're going to get 3 pi over 2n. And xn, or xn minus 1, is going to be pi over 2 times n minus 1 over n. So we have a is equal to 0. That's the lower limit of integration. B is equal to pi over 2. We have f of xi minus 1 to be equal to sine of pi over 2 times I minus 1 over n. And that is basically sine x, sine of xi minus 1. So that means the function f of x is equal to sine x. Now let's look at delta x. Delta x is going to be equal to b minus a over n. That's pi over 2 minus 0 over n. That's pi over 2n. But we don't have this expression showing up in a Riemann sum, and that means we have to do some algebraic manipulation. So what we have is, we have limit. This is a Riemann sum that we're given. Summation, I goes from 1 to n, sine of pi over 2 times I minus 1 over n times 1 over n. So what I'm going to do is basically put in pi over 2 here and also divide by pi over 2. This way we don't change anything and we still have the same expression as we started with. Now what we're going to do is factor out the 1 over pi over 2. This passes right through the summation. So we're going to get 2 over pi. We flip the fraction, we get 2 over pi, limit, n goes to infinity. I goes from 1 to n, sine of pi over 2 times I minus 1 over n times pi over 2n. Now this here is f of xi minus 1. And this is the real delta x. So we can now turn it into a Riemann sum. 2 over pi, integral from 0 to pi over 2, sine x dx. So let's rewrite that. The Riemann sum was given as 2 over pi, limit, n goes to infinity, n goes to infinity, summation, I goes from 1 to n, sine of pi over 2 times I minus 1 over n times pi over 2n. And we transform this into the definite integral 2 over pi, 0 to pi over 2, sine x dx. So this part here, this is f of xi minus 1. And we develop the real delta x, which is pi over 2n. This is delta x. This here is a function f of x, and this is dx. All right, let's look at a summary. So we were given a question, limit n goes to infinity, I goes from 1 to n, sine. This is the left-hand Riemann sum that we were given. Pi over 2 times I minus 1 over n times 1 over n. And we transformed it into two separate definite integrals with different limits of integration and also different functions. So we transformed it into 0 to 1 sine of pi x over 2 dx. And we also transformed it into 2 over pi, integral from 0 to pi over 2, sine x dx. These two definite integrals are in fact equivalent. So this integral and this integral have exactly the same value. In the upcoming videos, we'll be able to solve these integrals and compare these values, and you'll see that they are actually the same. All right, thank you.